All right, guys, in the last video, we talked about the cation columns of the house, or the anion columns, I'm sorry. And we talked about the stationary phase, and we talked about the prongs that are hanging off of the stationary phase. And now we need to talk about the cations, because we mentioned two of them. So on the cation column, I'm going to clear the screen out for just a second. But on the cation column, we're going to have the stationary phase. And we're going to have these prongs that come off just like in the anion side of the house. The difference is that these particles that are coming in are going to be positively charged. So I really can't have positive loaded particles inside of the column. Just as before, what will happen is that this positive piece will come in and say, whoop, no, there's positive, sorry, and I'm just going to kind of go on through. No retention is going to happen at all. So what I need to make sure of is that the cation column will have negative charges on the surface of the particle. That way, when that cation comes in the vicinity of the stationary phase, it's going to go, hey, how are you doing today? So you want to go out on a date? And then they kind of hang out with each other. And then that cation kind of user. So it goes on to the next one, the neighbor's house. And then it says, hey, what are you doing? You want to go on a date? And then it kind of stays there for a little bit, and then it moves off to the next one, and it kind of does the same thing, and then it finally goes through the column. That is how we get retention on the cation side. So cation columns are negatively loaded. That's what a lot of people get confused with. That's why I'm spending so much time on it. The anion columns, those are positively loaded, because that's the only way that these things can have retainment when it concerns the cations or anions that you're separating. Now, on the anion side of the house, we said that these are quaternary ammoniums for the most part. Okay, NH or NH4s can be there, but we often see the NR4s instead, and those carry with them positively charged. And we talked about the R groups that are pretty common, methyl groups or the 2-hydroxyethyl groups. On the cation side of the house, what's hanging off of here is typically an SO3, a sulfonate. And these sulfonate groups are going to lure those cations in, keep them there for a little bit before they release them and take them on. So that's where these columns begin to get a little different as well. So this is sulfonate loaded, this is quaternary ammonium loaded, and those give the stationary phase particles different surface charges. That's really what we're talking about right now. We're not talking about the stationary particle itself, but we're talking about the surface charges. They are slightly different, and this is how they get them. All right? So what you're seeing in this picture is basically a metrome representative holding some metrome columns that they are getting ready to install on the IC systems. And this is what the columns will typically look like, right? I mean, you compare these to the gas chromatograph columns, and they're nowhere similar, right? So if I take a look at the GC columns, these are typically spherical or wind up on themselves like a coil, and this tube is very, very tiny, and it's very, very long, and it's basically wound upon itself in a wire cage, and they can be 100 meters long if they want to be. Here are the columns for the IC instrument. They're nowhere similar to the GCs. Right? These things are typically pretty short. So here is a longer column that you're seeing him hold here and seeing him hold there. Those longer columns are typically anion columns. They need a little bit longer stationary phase packing in order to separate out very well. And the shorter ones really are the cation column side, and they don't need as much stationary phase in order to separate out. their behavior is a little bit different on the inside of the column, and they don't need the extra length in order to make sure that you can separate these ions from each other and to make sure that they are resolute on the chromatograph. So that's what you're seeing here in the picture. That's what a typical column will look like. And if you notice, these columns have this kind of weird thing that's sitting up here at the top. Not all of the columns will actually have that. The Metrome columns do, though. And what's happening is that the Metrome column has a computer chip that's here on the end of the column. And that chip is relaying information into the IC system. So that's what you're seeing up here in the IC box, and it can be just the basic one as well. Like, it doesn't have to be the fancy upgraded model. Ours have it, but that computer chip is relaying information to the software to help you keep track of everything that's going on in the systems. What's it basically telling you? Well, some of the information that you'll get from this is the number of hours that the column has been used. All right. A lot of people will like to do preventive maintenance, so they will like to change columns out before they start giving them a problem. And if they can have an idea of how long the column's been on there, working hour-wise, then this will kind of help gauge when the next time a column replacement should be coming around. It's also talking about the number of injections. Keep in mind that the number of hours doesn't necessarily mean anything, because what if your runtime was 10 minutes, and what if someone else's runtime was 60 minutes? That has nothing to do with the number of samples that get injected. It's just the overall runtime that you're using the column. So if I have 10-minute runtimes, I can inject 6 different samples onto that column during the time that I inject one sample on a 60-minute run. So the number of injections are also going to be pretty important. So that way it will help me gauge the usage of the column as well. A number of different types of samples getting injected, different types of compositions getting injected can dirty the column up much quicker than just looking at the number of hours that I'm getting the use out of that particular column. All right. Another thing that I can get from the database is the date of the installation. So I can go in and I can type in the date that I put this new column on, and it's just kind of like an oil change every 3,000 miles or every 3 months maybe is what your car manufacturer recommends. And if so, this will give me a date. And then I can go through and I can change out those columns whenever it's needed, and I can get a better idea of the longevity or the lifespan of these columns that I'm beginning to use in the laboratory. All right, so that's kind of where the column is going to be positioned on the inside of the machine. It's always pretty easy to get to, and that's what you're seeing right here in the very front, because you have to change them out. You have to put new ones on every so many number of months or so many number of injections or hours used. This is something that has to be convenient. It's also something that has to be easily switched out and done. And it is. I mean, you've got one screw down here that you need to unscrew, and you've got one up here at the top that you need to loosen up, and then this thing just pops out, and you put the new one back on, and you just tighten both ends back up together again. That's all that you've got to do. No big deal with them at all. Anybody can switch out a column if you need to. So we're talking about those columns, and we're talking about the stationary phases that's on the inside of those columns right now. So that's where you're going to be able to find them. That's what they're going to be looking like. So that way when you open up the covers of an IC instrument, you now know what to expect. And now you know what this big fat computer chip up here at the very top is for. Again, not all manufacturers use them. Metrome does, but not all of them will. Here's the problem, though, that I have with the computer chip. Right here's a connector, and this connector typically has a piece of tubing that comes out of the top and typically goes into the suppressor if it is a anion-based system, and then that will eventually go into the detector that's up here at the top. This means that this is going to get eluent, and that also means that you can have leaks that happen here at this spot. So if I don't tighten this piece up good enough, I'm going to get leaks, and leaks means liquid. and liquid has a tendency to short circuit the chip out. So it's not uncommon for these columns to short circuit themselves as far as the chip goes, and then they become defective and they will not relay information to the software anymore. I don't think they necessarily thought about that in a way. What they should have done is that they probably should have put the computer chip down here somewhere. That way, if this leaks, it doesn't really leak down onto the chip. And that way, if this leaks, well, it's going to have a harder time getting down to the chip because of that reason. But having it right up here at the very top, right up here at the connector base, where a leak can spring up, then that's an issue, and that's a problem that we got to deal with sometimes. So on our machines, what we have done is that we have deactivated the computer chip. You do not have to use them, and we've deactivated it because we always see this stupid error that gets kicked back over and over and over that says that the column is malfunctioned or the column chip has malfunctioned. And if you see that show up on our computer screen, then that is why that's there. We have not deactivated that chip for some reason, and we probably need to go in there and modify that method and clear that out of there so that way it doesn't try to pull information from that chip from that point on. Okay? All right, so that's kind of what I want to say about the column in this video. You now have a visual of what we're talking about. You now have an idea of what we need to be looking for. And now we're going to take a closer look on the inside of that column and really kind of discuss the details about what's going on. Not just with the fingers that are poking out with the sulfonate groups and the ammonium groups, but the stationary phase particle. What's going on with it?